In this video, we're going to have a look at integrating parametric curves, in particular find the area between a parametrically defined curve and the x-axis. So this question says that figure 2 shows a sketch of the curve C with the following parametric equations. X is 5t squared, take 4, and y is t times 9 minus t squared. The curve C cuts the x-axis at the points A and B. Find the x-coordinate at the point A and the x-coordinate at the point B. So part A, what we need to do is let y equal 0. We know A and B are when y equals 0. So y equals 0, which in turn implies that the expression for y in terms of t 9 minus t squared, also equals 0. And this implies, if we further factorise, that t, 3 minus t, 3 plus t equals 0. Difference of two squares, 9 minus t squared factorises to 3 minus t, 3 plus t, which then means that t equals 0, 3, or minus 3. So when t equals 0, this means that the x-coordinate is 5 lots of 0 squared minus 4 equals minus 4. So the x-coordinate when t equals 0 is minus 4. We can see that that must be the point A, because A is the only point of A and B with a negative x value. Therefore, at A, x equals minus 4. Next try when t equals 3. This implies that x equals 5 lots of 3 squared, take 4, which is equal to 41. And notice that we'll put minus 3 in there. We're going to get the same result. 5 lots of minus 3 all squared give us the same result. So we can conclude, therefore, at B, x equals 41. So now for part B, what it's asking us to do is find the area between the curve and the x-axis. So what we're going to do is find half the area, this area here, then double it. So we need to find the integral of y dx, as we always do with finding the area under a curve. The integral of y dx, which is equal to the integral of, well, we know y is equal to t 9 minus t squared dx, but now we need to integrate with respect to t. We've got t's in the expression, so we need to somehow turn that dx into dt. We're using a similar method of integration by substitution. We know that dx by dt is equal to 10t. So differentiating the expression for x, 5t squared minus 4, we get 10t, which means that dx equals 10t dt. So we can then replace the dx with 10t dt, which means we now have the integral of t 9 minus t squared 10t dt equal to, so let's multiply out the brackets to make this integration easier, which gives the integral of 9t minus t cubed times 10t dt, which is equal to, again, multiplying out the brackets, 90t squared take 10t to the power of 4 dt. And now we need to put the limits in. So now looking back at the diagram, we saw that when we were at the point A, the t limit was 0. And then when we were at B, t was equal to 3 or minus 3. So what we're going to do, we're just going to take the limit 3 for now. So when it hits the curve the first time, at B, we'll say t equals 3. And then when it hits A, t equals 0. So we're going to integrate between 3 and 0. Well, the integral is equal to, well, 90t squared integrates to 90t cubed over 3, or 30t cubed. And 10t to the 4 integrates to 10t to the 5 over 5. So take 10t to the 5 over 5, which is 2t to the power of 5, between 3 and 0. Okay, so that in turn is equal to, and let's sub in the limits, so 30 lots of 3 cubed, take away 2 lots of 3 to the power of 5, take, and if we sub in 0, we get 0. It's important to write take 0 because that acknowledges that you've subbed the limit in. There's a mark usually in these exam questions for subbing both limits in. So even if there's a 0 as 1, you should take 0. You should show that you've subbed the limit in. Okay, so now putting in the calculator, we get 30 lots of 3 cubed. Take away 2 lots of 3 to the power of 5, which is 324. Take 0, which is 324. However, we've only found half the area between where t equals 3 and t equals 0. This area here that I'm shading now. But there's another part of the curve between t equals 0 and t equals minus 3 here, which just so happens to be symmetrical. You can tell that from the diagram. Therefore, to get the full area, we'll times that by 2. Therefore, A equals 324 times 2, which is 648, which is the answer. For more videos like this, go to alevelmathsrevision.com or subscribe to our YouTube channel.